Hello, hi. Kushal Karthikeya from NIT Calicut BTech second year. I have started a new channel for engineering students. So why I have started the main aim of this channel to make the engineering subjects very easy and to learn in an innovative way. Most of the engineering students are biting the topics, but it was a time taking and a blunder because engineering subjects are useful in the daily basis. So it is useful to learn every basic term in the engineering subjects. So it will be useful in your daily basis and daily applications. And before moving on to the topic, if you have any queries related video and if you have any doubts, please suggest me in the comment section. I will rectify it and I will solve it in the comment section. Or if my English is poor, please tell me in the comment section. Or any related problems, please suggest me. I can rectify it from one video to another video, so we can discuss more topics. Okay, let's move on to the topic frequency compensation of an opamp. Many of them are not saying the heading definition. Why we are learning uh, the heading frequency compensation of an opamp? What is the uses? What are the disadvantages? Many of them are leaving, but it was a blunder because we have to learn why we are learning and what are the uses. So yeah, frequency compensation of an op-amp. It is an topic from the electronic circuits. Electronic circuits are divided into two parts, EC1 and EC2. It will be discussed in fourth sem and it will be discussed in fifth sem. So we are suggested that I have suggested that please run EC1 very detailed manner, so it will be useful for EC2. If you are not good in EC1, you are bad. You are also bad in EC2, so the grades will be dropper. Frequency compensation of an op-amp, it was an important topic. 5 to 10 marks will be coming from both NSEM and midsem. So I suggested it was an important topic, but most of them are leaving because in frequency compensation there are two related subtopics: how to draw a board plot given whether the system is stable or not. Most of them are leaving these two topics. I am suggesting to learn both the topics before that. But there are different videos to learn from it. But I have dumped all the videos into a single video. It is the video you can learn all the terms in this video. Let us go into the topic frequency compensation of op-amp. Why we are learning frequency compensation? Let us discuss whether the system is stable or not. Why we are discussing given system is stable or not? Because a system is there. By seeing it, we can say the system is stable. No, we can't say by seeing a system. But with a particular condition, we can say given system is stable or not. If it is not stable, we can make into a stable system by few methods. So the methods is known as only frequency compensation of open. So let us discuss whether the given system is stable or not. Okay, let's move on. Okay. Given transfer function of an op-amp related circuits, which is A of s is equals to 10 power of 5 by 1 plus jf by 10 power of 5 into 1 plus jf by 10 power of 6 into 1 plus jf by 10 power of 6. It is a transfer function and it is a frequency domain. There are two types of transfer function: time domain and frequency domain. It is in frequency domain because it is in the form of frequency, and every transfer function should be in the form of 1 plus jf by 10 power of 5. Okay, I'm repeating it: 1 plus jf by 10 power of 5. If it is in 3 plus or 5 plus, please take common the 3. So it will be make into 1 plus form, and after that b of beta of is equals to 1. It is in unit gain buffer open, so it is in beta of is equals to 1. Gain in dB. What is gain in dB? Many of them are doing gain in dB. What is the difference between gain or gain in dB? Gain means just A of s into beta of s, where gain in dB means 20 log A of s into beta of s. A of s into beta of s is equals to V naught by V in. V naught by V in is equals to gain. V output by V input is equals to gain. Log 20 log V naught by V in is equals to 20 log A of s into beta of s. Log AB. Log AB, what it means? Log A plus log B. 20 log A of s plus 20 log beta of s. So totally beta of s value is equals to 1. So totally 20 log A of s. 20 log A of s is equals to gain in dB of the given op-amp circuit. So getting what I'm saying? Let's move on. What is this graph? It is a board plot. Do you know how to draw a board plot? Many of them are having doubt how to draw a board plot, but many are skipping. In many videos I have seen, they're just drawing minus 20, minus 40, minus 60, but it was wrong because we have to discuss how to draw a board plot because basic student can't know how to draw a board plot. So I discuss how to draw a board plot. Okay, how to draw a board. For example, given transfer function, I have taken another example. H of s is equals to 10 power of 6 into 1 plus jf by f naught by 1 plus jf by f1 into 1 plus jf by f2 into 1 plus jf by f3. Given transfer function is in which form? Frequency domain from, and it must be in the form of 1 plus. If it is in any constant 3 plus, we must take 3 common, so it will be make into the 1 plus and make into the transfer function. Every transfer function should be in this form. Okay, here we have seen above the numerator terms are considered as in zeros, and the denominator terms can be considered as the poles. So f0, f1, f2, f3 can be considered as zeros and poles. F0 is in numerator, so it is in 0. F0 is in numerator, so it is in 0. F1, F2, F3 are in denominator, so it can be considered as in what it means poles. So getting what I'm saying? Okay, okay, please share up, not to be bored, please take a sip of water so you can be more active. It's my first class, so don't get bored. Okay, f0 is in 0 and f1, f2, f3 are the poles. Okay, let's draw in board plot. In board plot, the main terms are in y-axis, draw gain in dB, gain in dB, open loop gain, and x-axis we have to draw frequency and take the values f0, f1, f2, f3, and the given condition. I have forgot to tell the given condition. F1 greater than f0 greater than f2 greater than f3. You can take any conditions. It was vary from one condition to another problem. So I have taken this f1 greater than f0 greater than f2 greater than f3 to make it easier and to learn in an easier way. So okay, let's move on. Initially it is an open loop, and I will write it what it is. Open loop gain. It is open loop gain. It is an open loop gain. Okay, the initial point is an open loop gain. Until an polar zero exists, the slope must be constant. Until a zero or pole exists, it must be a constant slope. After that, f1 we are getting, because we are taking condition f1 is the lowest frequency of that. F1 is the lowest frequency. Here F1 is in denominator, so it must be in pole. Okay, I'm repeating it. F1 is in a denominator, so it must be in pole. Okay, pole. Whenever a pole is existing, the slope must be decreased by minus 20 dB per decade. Whenever a pole is existing, minus 20 dB per decade. Whenever a pole is existing, the slope is at minus 20 dB per decade. Whenever I am repeating a topic 2 to 3 times, please suggest, because it was an important topic of that. Okay, minus 20 dB per decade whenever a pole is existing. And after f1, it was decreasing by minus 20 dB, and after that f0. F0 is an what? It is a 0, because it is in a numerator, so it must be a 0. Whenever is 0 existing, plus 20 dB per decade. To the previous one. Previously, we are having a minus 20 dB per decade with minus 20 dB per decade plus 20 dB per decade, because we are having a 0. So totally 0 dB per decade. After the f0, see, after the f0, the slope is constant, because minus 20 plus 20 from the 0. So totally 0. And after that f2. F2 is in a denominator. Whenever it is in a denominator, what it is? It is in pole. And the for one pole, the degradation is minus 20 dB per decade. The slope is minus 20 dB per decade. Here, minus 20 dB per decade from f2 to f3. After f3, f3 is also in pole. So for two poles, minus 40 dB per decade. Previously, we are having a one pole. It is minus 20 dB per decade. After f3, f3 is also a pole. So minus 20 plus minus 20. So totally minus 40 dB per decade is the decay after f3. So I will erase it. So how to draw a board plot? We have seen how to draw a board plot by considering the main things are in numerator it is zeros, and denominators those are all poles. For one pole, the degradation is minus 20 dB per decade. For numerator, plus 20 dB per decade, plus 20 dB per decade. Consider another example. H of s is equals to a into 1 plus jf by f naught into 1 plus jf by f1 by 1 plus jf by f2 into 1 plus jf by f3 into 1 plus jf by f4. Tell me, What are zeros and poles? Okay, F0, F1 are the zeros, very good, and F2, F3, F4 are the poles. So okay, F0, F1 are the zeros, F2, F3, F4 are the poles. Why you are considering zeros and poles? Because in a numerator, what are the terms which are is and zeros? In denominator, they are all are poles. Okay. How to draw a plot for the given example? Considering open loop gain in y-axis and frequency in x-axis, and mark the values f0, f1, f2, f3. I have taken this f2, f3, f0, f1, f4. Let us uh, take in a different form. F0, f1 are the zeros marked in a red. Poles are marked in a black, so you can understand what are the poles and what are the zeros. Initially, the slope must be constant up to which any pole or any zero existing, and it is an open loop gain. Open loop gain means 20 log open loop gain 20 log of 10 power of 6. 20 log of 10 power of 6 means 120 dB, so it is in 120 dB. Here same it is 20 log a, 20 log a, it is. Please bear me to 10 to 15 minutes so we can get better knowledge. Promise me and I will trust you. Trust me, I will give you a better education. Okay. After F2, the slope is degradation by minus 20 dB per decay because F2 is in pole. So for one pole, the slope must be in minus 20 dB per decay. So it is a minus 20 dB per decay. You're getting that what I'm saying? Okay. After F3, minus 40 dB per decay. Why it is minus 40 dB per decay? Because two poles are existing. From F2 to F3, minus 20 dB per decay with the F2. After F3, F2 plus F3, minus 20 plus minus 20. So totally minus 40 dB per decay. And after F3, what is the frequency F0? If there is F0, it is in 0. So if there is any 0, the slope must be plus 20 to the previous one. Previously we are having a slope of minus 40 dB per decay. So totally minus 40 dB per decay plus 20. So totally minus 20 dB per decay after F0. Okay. And after F1, F1 is also in 0, which is marked in red. So it is in 0. Whenever it is 0 existing, the slope must be plus 20 dB per decay. So to the previously minus 20 plus 20. So slope must be a constant. Here slope must be constant. Okay. After that f4, f4 is in black, so it must be a pole. If there is any pole existing, then the slope must be minus 20 to the previously the slope is a constant, so 0 minus 20, so the slope is minus 20 dB per decay. Understand? Minus 20 dB per decay. I said important topics which are whenever a pole existing, the slope is minus 20 dB per decay to the previous one. If there is any zero existing, plus 20 dB per decay to the previous one, to which slope is constant, and the initial point is an open loop gain. The initial point is an open loop gain. Okay. The numerators are the zeros and the denominators are the poles. And the denominators are the pole. Let us consider another example. H of s is equals to k into s plus z whole power of a by s power of p into s plus p whole power of c. Find a comma b comma c by the given graph. By the given graph. By the given graph. By this example, you can draw any board plot in a very easy way. Okay. Uh, Given open loop gain and a frequency graph, it is a board plot. It is a board plot. How to draw a how to consider a b c values. Let us discuss. As we seen from the transfer function, as we seen from the transfer function and the graph, from the initially the graph is degrading by minus 20 dB per decay. Whenever a graph is minus 20 dB per decay, the slope is whenever a pole is existing. Initially the pole will be existed at 0. At 0, if there is any pole existing, then there will be a minus 20 dB per decay. We have seen that s power of b, s power of a in the denominator. So the 0 is existing at initially, but it is degrading by minus 20 dB per decay. So there will be only one pole at the 0. If there are two poles, see, if there are two poles means s square. S square means there are two poles in the 0. If there is two poles, then it is degraded by minus 40 dB per decay. But they given minus 20 dB per decay. So the drop is only one. So only one pole is existing at 0, so it is getting by drop of minus 20 dB per decay. After omega p1 the slope is constant. Why the slope is constant? If the slope by adding plus 20 the slope must be a constant. Whenever a plus 20 is existing, whenever there will be a 0 existing, here there is 0 existing because s plus z whole power of a. But if it is a must, if it a is 2, then it will minus 20 plus 40 minus 20, so totally plus 20. If a is equals to 2, if a is equals to 2, the total slope is plus 20, but here the slope is constant, here the slope is constant, so minus 20 plus 20 dB, so totally 0, so the slope is constant. Okay, minus 20 plus 20, so a must be is equals to 1, a is equals to 1, b is equals to 1, so totally constant slope is existing, constant slope is existing. After omega p2 the slope is continuously dropping by minus 40 dB per decay. Whenever minus 40 dB per decay exists, if there are two poles existing, whenever one pole is existing, the slope is degraded by minus 20 dB per decay to the previous one. Previously, we have slope of 0 dB per decay. So, with the previous decay, 0 plus minus 40. So, totally minus 40 dB per decay. So, at omega p2, there existing a two poles. There existing a two poles. So, we are getting a minus 40 dB per decay. So, a is equals to 1, b is equals to 1, c is equals to 2. So we are getting minus 20 dB per decay and a constant slope and a minus 40 dB per decay slope. Minus 40 dB per decay. Correct? Correct. Okay. Let us consider another example. H of j omega is equals to 10 power of 4 pi 1 plus j omega by 50 into 1 plus j omega by 50k into 1 plus j omega by 5 megahertz. Okay. Draw an board plot of the given transfer function. Okay, initially I know that it is an open loop gain 20 log of 10 power of 4. 20 log of 10 power of 4 means 80 dB. 20 log of 10 power of 4 which is 80 dB. Okay, 80 dB. Let's mark the frequency 50 kilohertz and 5 megahertz. 50 hertz, 50 kilohertz and 5 megahertz. You know right guys, so 50 hertz is a slower one, 50 kilohertz. Just mark it, and after that up to pole or zero existing the slope must be constant, the slope must be constant. Okay, the slope must be constant at 50 is it is in a, what it is in the pole, because it is in denominator, so the slope must be degraded by minus 20 dB per decay, so it will be degraded by minus 20 dB per decay up to another pole or zero existing. So after that 50 kilohertz is existing, which is a pole, which is an pole. If there is any pole is existing, the drop is by minus 40 dB per decay, because 50 is minus 20, 50 kilo is minus 20, so totally minus 40 dB per decay. In between, we have to take y-axis. How to calculate y-axis degradation? Okay, from 50 Hz to 50 kHz, there are 3 decays drop, because 50 kHz 50 kilohertz means 50 into 10 cube by 50, so 10 power of 3, so there is drop of 3 decades. For 1 decade minus 20, for 3 decades minus 60 to the previously one, 8 dB, so totally 8 dB minus 60, so totally 20 minus 20 dB per decay, not for 50 to 50 kilohertz. You are taking 80 dB and you are considering here 60, but it was a blunder, because minus 20 dB per decay. It is clearly mentioned that for one decay it is minus 20 dB per decay, 20 dB. So here existing the 3 decades, so minus 20 into 3, so totally minus 60, so 80 minus 60, so totally 20 dB. And after that 50 kilohertz to 5 megahertz, here how many decades we are existing? 5 megahertz to 50 kilohertz, so here existing 10 power of 2, so 2 decades are existing, so we are having a minus 40 dB per decay of the slope. For one decade 40, for 2 decades minus 80, so 20 minus 80 minus 60. From 50 kilohertz to 5 megahertz, at 5 megahertz we are having a minus 60 dB, minus 60 dB. Well, and after check whether the system is stable or not. Oh, we have started the journey from check whether the system is stable or not, and we have learned how to draw a portrait. Okay, I will continue the lecture in the next video. So up to which you are having any doubt, please tell me in the comment section so I can rectify it. So we can discuss many more topics. Okay then.